Hello viewers, I am Kausalya. Today we are going to solve problem number 3 under the topic Bode plot, that is finding the transfer function from the given Bode plot. The problem is find the transfer function of the system having Bode plot as shown, and this is our given Bode plot. Right? Can you say how many parts it is having? It is having 4 parts, that is 1, 2, 3 and 4. And each parts are here given with the respective slope values. Right, and here we are given 2 values of frequencies. One is 0.8 and another one is 1. And here the magnitude value is given as 36.13. So these are all the given data. So as we all know, the first slope is contributed by individual s term which is present in the transfer function, right? So here what is the value of slope? The slope is plus 40 dB. Can you guess where the s is present? Here not s, we are having s square because a single s contribute a slope of 20 decibel per decade. Here we are having 40, right? So the term is s square. Right, now where this s square is present, either in the numerator or in denominator? It is present in the numerator because the slope is given with a plus sign here, right? So plus 40 decibel per decade, this slope is contributed by an s square term which is present in the numerator, right? We will proceed now. So as we see, the first part has an s square term and there is a constant. So here we are including k s square, right? So what is the value of magnitude A? The magnitude is given by constant along with the individual s term present in the transfer function. So here we are having a k and s square. So magnitude, we will write it as 20 log k, that is s is substituted by omega here, omega square, right? Then here this is in logarithmic multiplication, right? K into omega square. So this can be written as logarithmic addition. So 20 log k plus 20 log omega square, right? So again 20 log k plus this omega square, we can move this 2 to the front side. So 2 into 20 log omega, which is nothing but 40 log omega, right? So this is our expression for magnitude A, right? Now we will go back to the problem. Here at a frequency of 0.8, the magnitude is 36.13. So just note down the values here. So magnitude is 36.13 and at a frequency is 0.8. Okay, just substitute the values here in the above expression. So when you substitute, here we are getting, you see 40 log 0.8 gives minus 3.87. When you move this minus 3.87 to the left hand side, that becomes plus 3.87. So we are getting the answer as 40. Right. The next step is I am going to move this 20 to the left hand side. So 40 by 20 gives you log k. How to find k? So finally k is given by 10 to the power 2, which is nothing but 100, right? So our transfer function 1, that is for part 1, is k s square and the value of k is found to be 100. So just write down the values. That's it. Right. Now we are moving to part 2. So in part 2, what is the change? You see here I am having plus 40. It has changed to plus 20. Right. So at a frequency of 0.8, right, the slope changes from 40 decibel per decade to 20 decibel per decade. So I am having 40, right, and my final answer is 20. So what should be added here? Here minus 20 should be added. Do you people accept? Yes, 40 minus 20 will give you 20. What does this minus 20 indicate? There is an s term in the denominator part, right? So here our transfer function gets modified as, already we are having 100 s square. So write that 100 s square as such. Here we have to include minus 20. So minus 20 denotes a term in the denominator. So 1 plus some term with s. How to find this term? We have to take the reciprocal of this frequency. So 1 divided by 0.8 gives you 1.25. So here I had written the final expression as 1 plus 1.25. Yes, right. Now we are going to look at our part 3. So in part 3, what happens? The value of slope is 0 decibel per decade. So initially it is 20 and now it is 0, right? And here the value of frequency is 1. So you see plus 20, initially it is plus 20 decibel per decade, now it is 0. So initially I am having plus 20 and now it had reduced it to 0. So what should be added here? Here again I have to add a minus 20. So addition of minus 20 says that again there is a term in the denominator, right? So write the previous terms as such, that is 100 square by 1 plus 1.25 yes. So this minus 20 indicates again there is a term in the denominator. So 1 plus some term with s. How to find this coefficient of s? We have to take reciprocal of this frequency. So 1 by 1 is nothing but 1. So here I had simply written as yes. Right. Now we are going to see our part 4. So what happens in part 4? Here the value of slope is minus 20 decibel per decade. Initially it is 0 and now it is minus 20. So here the value of frequency is 4, right? And here from 0 decibel per decade to minus 20 decibel per decade is the change of slope. So initially I am having 0 and finally I am having minus 20. So what to be included? Here we have to include minus 20. So this minus 20 indicates that there is an s term in the denominator part, right? So you write the remaining terms. You see these 3 terms should be written as such. So just write the terms as such. Here again we have to include 1 plus some number with s. Right. So how to find this number? You have to take reciprocal of this frequency. So 1 by 4 gives you 0.25. So finally I had written 1 plus 0.25 yes. Right. So this is our final transfer function. When you look at the problem, how many parts we are having? You are having 4 parts, right? Similarly, when you look at the transfer function, you will be having 4 expressions, that is 4 elements. You see 1, 2, 3 and 4, right? Hope you people understand this problem. If you have any doubt, let me know in the comment section. Thank you.